tangent is derived from the Latin word tangens, which means touching. Thus, a tangent to a curve is a line that touches the curve. In other words, a tangent line should have the same direction or slope as the curve at the point of contact. We can choose a point along the parabola and draw a tangent line. However, there are curves where we cannot use this approach. So instead, we use a secant lines. As delta x approaches a certain value, in this case, 1, we get closer and closer to the point P. At 1 and 1, the slope of the secant line then approaches the slope of the tangent line. And this limiting value, or the closest value, is what we define as the derivative at that point. We may wish to approach x equals 1, either from the left side, or from the right side. We can also choose the increment or the value of delta x. We see that the slope changes and the value gets more equal to 3. We use the formula to find the first derivative of f of x equals x cubed. Finding the first derivative gives us the formula to find the slope of the tangent line passing through point P. With coordinates 1 and 1, we see that it is equal to 3x squared. We substitute 1 to the variable x and find out that the slope is equal to 3. We can also use the binomial expansion to find the formula for finding the derivative of f of x equal to x raised to n. We see that the derivative, or f prime of x to n, is equal to n times x raised to n minus 1. The first derivative is also the instantaneous rate of change at that point. This is also equal to the slope and can be written as. The first derivative is widely used in real-life situations to analyze how things change. For instance, in physics, it helps determine the speed of a moving car by measuring how position changes over time. In economics, it reveals how profit changes with sales volume. It also describes how fast temperatures rise or how steep a hill becomes.